Living Room Logic. Welcome back to Season 2 of Living Room Logic.
This episode is all about the world's fascination with Mars, how many times we've tried, and often failed, to get stuff to the Red Planet, and we weigh up the pros and cons of sending humans there.
Give the podcast a huge boost by following or subscribing to it wherever you get your podcasts. And check out our Facebook, Twitter or Instagram at Living Room Logic to join our logical following. This season is supported by FameLab Ireland.
Welcome, everybody, to another episode of Living Room Logic, where two scientists who know too much about very, very little talk about things that they love to talk about. And this week we have a hell of a thing to ponder on. A hell of a thing. A red thing. Mars. The fourth planet from the sun, that fourth rock that lights up our sky, that's been making us think and think and think for a long time. The ancient Sumerians looked at it and thought it was a god of war and plague. And this was also continued by the Romans. We use it as a symbol of masculinity. The symbol for Mars is the circle with the arrow to the upper right. And as humans have looked at the stars forever, wondering if we are alone, we pondered the man on the moon and the Martians of Mars. And a planet which is too close to ignore, but really, really different. It's only half as wide as Earth and has 15% of the mass, 37% of Earth's gravity. It takes 687 days to orbit the sun, even though the length of a day on Mars is only 24 hours and 40 minutes. It has 1% of the atmospheric pressure of Earth. This is so low that when water is melting from ice, it cannot exist as water and it will sublimate, which is when it goes straight from ice to gas, skipping the water step because the atmospheric pressure is so low. The Earth's average temperature is 14 degrees, and the average temperature on Mars is minus 46 degrees. And none of that makes me want to visit the place. If this was a holiday destination, I would have declined. But we're still obsessed. Maybe the grass is always greener, or at least in this case, redder. And recently it was in the news that we sent a new robotic creature, which we're all obsessing over. And Aidan's going to tell us a little bit about that, about Percy.
Oh, Percy. I could sing an old Irish song about you.
Don't.
It's the new rover that they just landed successfully in a place called the Jezero Crater. And I'll talk a little bit about the Jezero Crater and why we care about it. But Perseverance is pretty much one of the most complex space rovers that humans have ever built to date. It has lasers. It has X-ray, it has radar capabilities, it has 19 different cameras pointing in every which direction, taking pictures and videos, everything that it sees. The one they uploaded last week was phenomenal, of the heat shield popping off and you being able to see its descent towards Mars and it actually landing. And I'll talk us through what's called EDL, or entry, descent and landing. Absolutely phenomenal. So this thing has a nuclear-powered battery made of plutonium-238. We've already talked a little bit about these isotopes in Season 1. Basically, this thing decays at a constant natural rate. It's really bad for humans, but it's really good at keeping Percy nice and cosy warm, especially during the night when it gets frickin' cold in Mars. It can get up to minus 150 degrees Celsius at the South Pole in the winter. Pretty bleak. So Percy has to have a lot of insulation and a really decent heat and energy source. So that's what he's got. The thing is, though, Percy cost about $2.7 billion to build. So what they do in NASA and the JPL, which is also known as the Jet Propulsion Lab, is they build Percy to send to Mars, but they also build a second copy, a duplicate, exactly the same, in Pasadena in California. And for every single encounter or situation that Percy gets into that they need to work out really fast, they do it first on the one in California and they simulate it and then they do it on Mars.
That's really cool.
So Percy's actually the biggest as well. He's the largest rover to ever be sent to Mars. He weighs about 1 metric ton It's the largest payload that's ever been sent to Mars. And so that's the same weight as a standard 4-door car, or at least in Europe it is. Because we know Americans, how you like your big cars. The thing is though, like, there's been a lot of rovers, okay, and we'll talk through them, but the difference and the thing that kind of puts Percy out in front is that none of these samplers have actually gone out and collected core samples to be returned to Earth. And that's Percy's main objective, is to actually, there's going to be a retrieval mission that will launch in 2023 at the earliest, and Percy's going to take these rock core samples and do a hell of a lot of other stuff, but those samples will be pooped out onto the Martian floor in these safe little sample bottles, and basically another rover will be sent with the capability of shooting those in a rocket back home, which is just so cool. And the thing is though, we need really this. Cool. We need to bring the samples back to Earth, because there's only so much weight that we can shoot to Mars in a rocket. This 1 ton is kind of like the threshold we're at for sending payloads, much farther than the distance to the moon. One other really cool thing that Percy's going to do is this experiment called MOXIE. And you might know, if you watch The Martian, Matt Damon,
great movie.
Being a botanist, his oxygen was being depleted in his encampment that was absolutely falling apart, and he had to create oxygen somehow. And so he decided to do it by using water and taking the oxygen out of the water, and it's a very dangerous, explosive method, and he nearly blew himself up. MOXIE's quite similar, but without the explosiveness, in that Mars's atmosphere is very high in CO2, carbon dioxide, and the dioxide part is what they want to take out in that experiment and see, can Percy, in the MOXIE box, it's this gold-plated box, can it create oxygen from the CO2 that's naturally there in Mars? And if that's the case, then it would be quite easy to send humans so that we could have an oxygen supply, and we could basically create high-powered jet fuel to send us home again. So really cool. One more exceptionally cool thing that Percy has, and it's this cute little helicopter called Ingenuity. I didn't realise that this was so cool, because when you look at it, it looks really simple. It looks like a drone.
People who can afford a drone can get a drone.
But the thing is, Mars's atmosphere, as you said, is extremely thin, and it's something like 1% the density of Earth's atmosphere, and so it's actually extremely hard to fly anything. So if you want to go back up, you need an incredible amount of power to push the air, because there's barely anything to push. The reason helicopters and planes work in Earth so well is because they're pushing that dense atmosphere and the air, literally pushing it through engines and through rotors. This Ingenuity is like 83 grams in weight. It's super light. It's got these 2 rotors. One is going clockwise and the one right underneath it is going anti-clockwise, and they're like a meter long on either side. It looks like it's going to fall over. Whoa. It looks really imbalanced. This is what you need to create the lift in Mars' atmosphere. And so they've never flown something powered flight in Mars' atmosphere before, and so this is what's just going to be so cool, because if we can figure out how to fly in Mars' atmosphere, we can just scale it up and keep scaling it up. But you can think that, like, to lift 83 grams, to have a meter long, 2 meter long rotors, could only imagine if you're, say, you got an 80 kg, 100 kg human, how big those helicopters would have to be, right? So it's something that you just don't realize, that it's really hard to fly when you have a thin atmosphere, which is just so cool. So this thing launched in the 30th of July in last year, which is 2020. They used a NASA Atlas V rocket, which is one that isn't reusable. And it took it 7 months, traveling at about 40,000 kilometers an hour, exceptionally fast, to get from Earth to Mars. And there's this really cool thing about the distance between Earth and Mars. Every 2 years, the 2 orbits line up quite well. And that's when all of the agencies send all their stuff. So actually 3 missions went at the same time that year. China and Europe also sent something because they were like, the time is now. We have to wait another 2 or 3 years if we don't send it now, you know? This is where we get to actually when it is just about to land on Mars. And that whole thing is one of the coolest processes. Just before we get into it, entry, descent and landing, or EDL, is also known as the 7 minutes of terror. Percy is entering Mars' atmosphere at 15 times the speed of a bullet, so it's slowed down to 20,000 kilometers an hour. Slowed down. It's still going incredibly fast, and the reason it's called 7 minutes of terror is because not only does it take 7 minutes for this whole process to happen, but comms on Earth are out of the loop and don't get the signal for 8 minutes. So as soon as it starts entering Mars' atmosphere, it's completely on its own, and that's why they have a bunch of really cool automated technology on the rover. Upon entry to the atmosphere, the heat shield takes the brunt of the energy, and there's thrusters on the back of the capsule that are keeping it steady. Once about 99% of that energy is dissipated by the heat shield, a supersonic parachute is deployed and the heat shield pops off so that the radar on the rover can take pictures of the ground and really in minute amount of time map where the hell it is in reality and compare it to what's in its database. And it has an AI system that allows it to autonomously find a suitable landing spot in the Jezero crater. At this stage, even with the parachute, the rover is hurtling at the surface of Mars at about 300 kilometers an hour. But the rover has one more thing to show off. It detaches from the space capsule, which had the parachute attached, and is now only attached to a sky crane with downward facing thrusters that fire full blast to slow the rover down to 3 miles per hour. So it's attached to this sky crane, and then the sky crane drops it down at about 10 meters with 4 ropes. It's crazy. Just above the surface.
So basically they have to slow down this thing crashing onto Mars to 3 miles per hour, which is a serious deceleration, and then float
just above
in the sky.
Yeah, exactly. And then the sky crane lowers it down, and just above the Martian surface, the ropes just detach and goes boop, and it kind of springs onto the floor, and the legs are quite suspended so that it can kind of bounce a bit, and take all the shock. And then the sky crane actually flies off and crashes several kilometers away. But yeah, it's so cool. At the end of that video that they put up, your man's just like, Tango Delta, Perseverance has landed. And everyone just freaks out. It's fucking amazing.
Oh, I'd love to be in the meeting where they decided, okay, and then what happens with the sky crane? And someone just goes,
what do you mean what happens to the sky crane? We didn't have that in our report, what to do with it.
Yeah. This is the plan to get the rover to land. It kind of reminds me of when the space shuttles are going off and the boosters are dropped off somewhere over the ocean. Yeah. And they just, it's like, bye. And it's like, yeah, we knew we weren't going to recover them. But even when you said sky crane, I was like, what the hell is a sky crane? It's literally just hovering and lowering something that's a ton onto the ground. That's wild.
I think the reason they came up with it was because, and we'll talk about the previous missions, but basically the previous missions didn't have this.
No.
And if you actually attach the thrusters to the rover, there's a chance that something really bad can happen, and that you can actually really screw up a lot of the instruments on the rover or on the lander. And so attaching the thrusters to this thing that just flies off and blows up somewhere is a lot better off for the actual thing that you want to do the science with.
On that, how did we get here? To this situation?
Here's where we are. We're sending things the size of cars to Mars.
And when we started, it was in 1957, early stages of the Cold War. We'd heard about this, America versus Russia. This is our part 2 of that discussion, where before we were talking about nukes and stuff, and now we're talking about the space race in more detail. And USA got to the moon first, and Russia got the first person into space at the same time as all of this. But since it was such a total failure, we don't talk about it, because at the same time, throughout the 60s, they were trying to get stuff to Mars. And I don't mean like, yeah, there was one or two failed missions. I mean, there was a significant amount of failed missions. Okay, so like the USSR tried to launch the Marsnik 1 in 1960, which exploded without leaving Earth. Then
goodness.
And then they tried to do it to the second version, the Marsnik 2, which also exploded just off liftoff at the same time. Then the USSR was like, okay, Marsnik is cursed. Let's go with the Mars one. Yeah, that's much better. And the idea was that this would be a flyby mission. So it would fly by, take photos. And it left Earth in 1962. And it was meant to take photos in 1963. But before it got to Mars, it had a radio failure. And they just lost communication with it. It just...
Oh my God, just decided to go off on its own thing. Like, I want to be my own robot.
I'm going to see the universe. Which I'm sure it did. So they finally got one out of Earth. And they had it for a year, Aidan. They had it for a year of like following it and setting it up. And then one day it just didn't call her back. It just didn't talk back, man.
Just left you on red.
It's crazy. So then they were like, okay, maybe not Mars either. So then they had the Sputnik 24, okay, which was a satellite mission, which again meant to be a flyby. This was in 1962 as well, and it didn't get out of Earth's orbit. It went into Earth's orbit and then went sploosh.
This is 3 splooshes. This is 4 splooshes.
Well, no, 3 splooshes and a didn't get a call back.
Oh yeah, I forgot about that.
And then in 1964, NASA, they came into the program, and they had their Mariner missions, and their Mariner missions were the missions they'd send to planets to have a look and see. So they had the Mariner 3, which was great. It was fine. And then it had a solar panel failure. So obviously our solar technology wasn't so hot back in the day. Later in 1964, we had the first successful flyby mission to Mars. And this was by NASA with the Mariner 4, right? And it flew by Mars and returned 21 photos in 1965. And this was the first clear photos that we took of Mars. 21 photos. Okay? And it was huge. It was absolutely, absolutely massive, right? And then it took 4 years later to send more Mariner missions to Mars. And it was NASA again, and they sent Mariner 6 and Mariner 7, which went over parts of Mars to take like at a closer distance, so they were much closer to the planet, except the parts that they went over just happened to be extremely hit by asteroids. So this was the first time we got a proper look at the surface of Mars, and they came to the conclusion, oh, Mars is pretty much just the moon, because it was covered in craters, even though we now know that that's not true. So, we kind of got that false identity of Mars, and we were like, oh, that's all it is. It's just like the moon. Anyway, the USSR, they had a tough time, but they didn't stop trying. And in 1969, they sent up another mission, which also went sploosh, crashed before leaving the Earth's orbit. Then in 1969, they had another one which didn't even get through launch and went sploosh again.
Oh my God.
Man,
do they have any successful missions?
We will get there.
I just want to win. I just feel bad for them at this stage.
They had it tough, man. Then NASA in 1971, they came out with Mariner 8, which went sploosh. So it wasn't all great for NASA either. This was after 7 other Mariner missions, which were solid. And then they had their own, didn't even get through launch.
Wow.
So the USSR then in 1971 also came out with the Cosmos 419, which launched but went sploosh out of Earth's orbit. I'm telling you. So all of these missions that were just like tough going, they were just to do flybys. And it wasn't until later in 1971 that they started attempting to get orbiters and landers. So these aren't rovers. These are landers. So they land and they try to take data from wherever they land, send it to the orbiter, and then send it from the orbiter back to the Earth, right? And in 1971, the USSR sent Mars 2, and this crash landed. They got it to Mars, but it crashed on the surface of Mars.
At this point,
lander.
that's a success.
Yeah.
They're like, yeah, we hit it.
Yeah, exactly. And interestingly, now that that we were talking about it earlier with how thin the atmosphere was, I guarantee you that the scientists weren't prepared for the density of the atmosphere, because at this point they wouldn't have a clue. They'd have no idea.
They wouldn't have really known, yeah.
So it'd be very difficult to prepare landers, right? And in the same year, they had a second mission sent out, which was the Mars 3 from the USSR, and it landed. It worked for 5 seconds, and then just decided to not work anymore.
Oh, come on.
I know. But the orbiter that they sent worked. It went delightfully well, right?
Is this a Mariner or a Mars?
This is Mars. This is USSR.
Okay, what? Yes!
Yeah.
What a win. I feel good for them. I feel like they're the underdogs right now.
Man, they just had tough times with
in
Mars.
terms of space exploration.
Yeah, like there was people were comparing Mars to the Bermuda Triangle at the time, and they were just kind of like,
"Oh, you're going to Mars?" Yeah.
Yeah. Everything that goes there vanishes. But people were kind of using this as a theory that there was life on Mars because it was almost too hard to get there, and they were saying that oh well, obviously everything that you're trying to go there is being shot down by the intelligent Martians living there. I don't know, I just thought it was cool. Anyway, NASA came in that year and kicked everyone's butt with Mariner 9. And the reason this was cool was because Mariner 9 was a flyby mission that wanted to catch the orbit, and it did. And it got there, and there was a huge dust storm. A huge dust storm that encompassed the entire planet. It put off their mission by 6 months because they had to wait for it to calm its stuff down, And
wait, so they basically couldn't map Mars because they couldn't see anything?
There was nothing to take a photo of other than a big dust cloud.
Oh my God, that's insane.
But what was really cool, right, is they could come to some conclusions, because as the dust cloud was settling, some things appeared above the surface. So if you have a dust cloud settling, they could see things that were really high up versus the things that were really low down. So this was the first time that they were able to see that there were ancient volcanoes on Mars. This was the first time that they saw it, because before, from the top down, it might look like a crater. You couldn't be certain. But when they were looking at that. But this was also the mission, this NASA Mariner 9, that first saw the Valles Marineris, the giant gash in the side of Mars. If you ever look at a picture of Mars, there is a huge canyon, right? And this is called the Valles Marineris. Marineris named after the Mariner 9.
Oh, cool.
Which found it. And it was the first time we saw it, which is kind of like, you'd think we would have seen it before that, but absolutely not. This was the first time people were like, oh God. And it puts
that is crazy.
Yeah, it's weird. And it puts the Grand Canyon to shame. This thing is huge. But it did really, really well. So remember, the first mission that did a flyby got 21 photos. This badass mission got 7,329 photos. And it was just a huge moment in actually getting a good look at Mars.
And I really like when you said that when a bad thing happened, something actually good came from it, that they would have never have noticed those humongous peaks and those humongous troughs when this dust was dissipating.
Yeah.
It's just a happy little accident.
A happy little accident. And yeah, no, but absolutely. It was one of those things because everyone was looking at the pictures and they were like, gosh, Mars is just being a nuisance. 2 years after that, the USSR went ham and they sent out the Mars 4, the Mars 5, the Mars 6 and the Mars 7, which kind of at this point feels like they're shot. Yeah, they're just orbiters and landers trying to get something, something to stick.
In terms of the splooshometer, like how sploosh did they go?
So Mars 4 didn't sploosh. It left Earth's orbit and it went to Mars, but it missed. So it didn't catch Mars and it just flew by. It just... So it just was...
No.
Mars 5 Mars 5 got to Mars, orbited for a few days, and then just stopped working.
Oh my God.
Unexplained. The Mars 6, it got to Mars and it orbited and it was a total success. But it had a lander and the lander just splooshed. So again, they just couldn't get the lander to work, which, you know, is not surprising. So far, there wasn't really any successful landers. And the Mars 7 is my favourite because the Mars 7 was a huge success. The orbiter got into orbit. It was fantastic. And they dropped the lander onto the planet Mars and missed. They missed. They dropped the land. Imagine holding a rock and dropping it to the ground and missing. That's what happened. That's effectively what happened here.
It's totally defied physics, and I was like, I'm going home. The second thing to go home, the sky crane, and now this.
Like, after a series of unfortunate events for the USSR, up until the Mars 7 orbiter lander mission in 1973, and that's what happens. They missed.
Oh my God.
How can you not just absolutely appreciate that?
So difficult.
To get something to land on Mars, as we were just discussing with Percy, is really hard. And that's why they had to come up with this wild idea to...
Because it is wild.
Oh, it's a completely nutcase idea, and we'll keep going with nutcases ideas later in the episode. But, like, they established that they could shoot things at Mars and it would either crash or miss. Scrounge break. Do you ever want to just listen to two overly educated, privileged white men talking about the wonders of science? Me too, right? Even better when they do it for free. Oh, the humanity. Donate to our cause at patreon.com/livingroomlogic and get early access to episodes, original music, and ridiculously attractive merchandise. NASA finally had some success in the orbiter-lander duo in the Viking missions, didn't they, Aidan?
So the summer of 1975, NASA is on a high from the past couple of missions. They had a couple of successful ones.
Like the moon landing.
Yeah. Oh, yeah. Like throwing those guys at the moon and actually getting there and back. So these Viking landers, there are actually four things. There's 2 landers and 2 orbiters. And they actually decided to send 2 just in case. They were like, we're going to send 1. And if the first one just totally splooshes, we're going to send the second. And hopefully we will just adapt. The interesting thing, though, is that, you know, there's nearly 40 or 50 years between this and what we just talked about with the Perseverance lander that just happened. And weirdly, the landing sequence is actually quite similar, but just with some very key differences. First of all, there was no clear landing site. They threw this thing at Mars.
Just hoping for the best.
And they were like, we're gonna hit Mars. We're gonna hit it. We're gonna get that. We're gonna make the shot, but I don't know if it's gonna be a hole in one. So the idea was that they would send this thing nearly to Mars, and at that point then they would make an informed decision where they will put it. And so they can kind of tweak their trajectory so that they can land in a certain area. So that's something that's changed massively, is the radius of the landing area, because Percy kind of had like a landing site, like a small little couple kilometers. That's where we're going. AI is going to get us there. They basically had to choose a landing site based on pictures that they got from the thing. They printed out pictures that the lander sent them, and then they all got around in a round table and were like, okay, what the hell are we going to do? We're going to go here. We'll let X marks the spot. The other major thing was that they didn't have a sky crane. And that was massive, because that was the thing that helped Percy really slow down in those last couple meters, which is kind of like the most important part, because that's when you start, when the unstoppable force hits the immovable object. So, you know, instead of the sky crane, 15 different thrusters were actually attached to both of the Viking landers. They had a very similar supersonic parachute that opened up at a certain distance away and at a certain speed. So when they it's actually when they slow down to a certain speed, it triggers heat shield gone, parachute out, let's go. And so the only other major difference is, instead of the sky crane, they have these really long suspension legs They're like really heavily suspended, like super spring loaded, so that they can take an immense amount of a hit and still not hurt all the stuff that's in the core of the lander. Wow. And that is exactly what happened. The first lander was a couple of months before the second one on the orbiter. The orbiter for both worked perfect. And the first lander, pretty much when they got the first picture back, they were in a rock field, like a really hazardous rock field. And actually, it turned out that they landed right in the middle of this rock field that if you were a rover, you might as well be a lander because you couldn't move. Just boulders and sharp rocks everywhere. Turns out that one of the legs the suspension worked and was completely and utterly shoved up. And it was at like an 8-degree tilt. And so, it was just incredibly lucky. Like, they fell into a freaking rock field, like... but it survived. And so this thing hit the ground at like 8 kilometers per hour, which is pretty big thud, like. Yeah. And it was fine. And it was grand. And the first one landed and the second one landed on the other side of Mars, not a bother. Mad. And they both worked for years, and it was such a success. Both of them worked well. Both the orbiters worked amazingly. But the really cool thing about this Viking mission is that it is the first thing to actually get down and take some samples of the Martian dust and rock and test it for life. They were testing for current life, extant life that is alive right now, pretty much microbial life. So, but just before the Viking landers did their life experiments, they actually figured out, they were the missions that figured out that atmosphere is 1% the density of Earth's atmosphere, and that, damn, the JPL people just got it right. They made a really good assumption in that it was a very thin atmosphere and that it was mostly made up of CO2. This was something that we didn't know. And it had CO2 and methane and nitrogen and not a lot of oxygen. And so there were 3 different life experiments, okay? One was called a gas exchange experiment. But really what it did was it just scooped up some Mars dust or some Mars rocks and chucked it into this jar, what's called a microcosm, and simulated Mars conditions and going, is there going to be some changes in the gases that would only be caused by life? And nothing happened. They didn't get any organic signatures in the gas exchange. The second one was somewhere in between Earth and Mars conditions. And so they put some Mars rocks and Mars dust into a jar and put in a bit of water, a bit of nutrients, and they got nothing. And then they tried this thing called a photosynthesis experiment. And they put in the perfect nutrients that you would need for Earth life to give off chemical signatures in the air. And they got 2 positive results on the first day. And they were like, what? Okay. And they did it over and over and over again for several years, both of them. And those were the only 2 that they got a positive result.
That's so weird. So
that really freaked people out. But it is very statistically likely that it was called a false positive. And they happen all the time in science.
Yeah.
You hear of people say with getting a positive COVID test in the current world situation, and sometimes it's actually not the case. These things happen. So it was a false positive, unfortunately. And actually a lot of researchers went and did a lot of science to figure out that there's actually ways that inorganic or non-living processes, chemical processes, can produce these compounds in a very strange and rare situation. But that's probably likely what happened. That was incredible. And this really showed for the first time that there isn't life on Mars. At least not now. And this was a huge buzzkill for the scientific community. They were really banking on there being some life, or at least some signs of something. Actually, at the same time, those orbiters were doing God's work. They were taking loads of photos of Mars, and they actually mapped about 97% of the Martian surface, which had never been done until then. The Mariners had done a really good job, and actually the Mariners kind of continued on after the
Yeah.
Viking missions and did really well in mapping the Martian surface after. But at this time, there was never such a good resolution for looking at Mars, right?
Of course,
And
yeah.
so what we saw were like these diverse features, like there's water ice sheets on the Martian poles, and they mapped those really well. They mapped the differences in the hemispheres. So as you said, the southern hemisphere is riddled with craters, and very large ones, like, you know, maybe tens or hundreds of kilometers in diameter. And these huge valleys and vistas. And you talked about what is it called again? That
The
massive
Valles Marianus.
Yeah, that is just incredible. So they got that in better detail, especially along the equator.
Mm-hmm.
And then one of those highest peaks that you talked about is actually the largest volcano in the solar system, called Olympus Mons.
It's a hell of a name.
Yeah, it is pretty cool,
Yeah.
isn't it? But the thing is, it's called a shield volcano, and that just means that when the volcano erupted, the lava was really fluid and kind of spewy. And
Yeah.
it like spewed out over miles and miles and miles. And so you just have to think, like, how big is this thing so that it's 3 times taller than Mount Everest?
It's
How much
outrageous.
lava is it spewing out? That it's still that big.
Yeah.
Just an insane amount of rock being spewed out. So incredible. The Viking missions were a total bloody success.
Yeah.
And so that kind of brings us up until maybe the kind of rovers and observers that you hear today in modern times. And Andrew knows a bit about that.
Well, just a little bit, because the Mars Observer, right? So all the Viking missions were a huge success, like we were saying, and there honestly wasn't a need to be launching too many things for a while. So it wasn't until the 90s that NASA sent the Mars Observer. And at the time, it was a huge mission. Like we just said that there was rovers worth $2.7 billion. You know, that was Percy, wasn't it? Was this in the 90s? This was $813 million, which is a lot. You know, it's a lot at the time.
And it's huge for the time, yeah.
Yeah, it's huge for the time. And they sent it out in 1992, and it stopped working in 1993.
Okay.
And it was interesting because, towards the 90s and until recent times, people stopped caring as much. And this led to the movement towards developing smaller and cheaper missions. And this was, look how far that got. But anyways, but this was called the FBC program, which was faster, better, cheaper.
Oh my God.
But it didn't stop amazing work getting done. One of the most successful missions ever was the Odyssey. Great movie. But also a very, very good satellite surveyor that was launched in 2001. And the amazing thing about the NASA Odyssey is that it is still working. It is still up there, still working.
Whoa.
So in 2010, it broke the record for the longest serving spacecraft, and it is still going, still sending back signals, and it has
That is incredible.
So remember the first time I said that the first flyby took 21 photos, and then the next one took a couple thousand.
Oh God, is it millions? Is it?
No, it's 350,000 images.
Wow.
Another surveyor was the European Space Agency, which sent up the Express, which was in 2003, and it was meant to have a lander as well, but the lander went sploosh. But again, the orbiter got there, and again, still working, 2003. So the Odyssey is the longest serving, and the Express is 2 years behind it.
So we've really fine-tuned these orbiters. We've got the orbiters down.
Yeah, and in 2004, we developed the 2 rovers, which was Spirit and Opportunity. And total successes, because they were the rovers that first showed evidence that at one point in time Mars had running water, that there was at one point in time evidence of flowing water on Mars. And that again, it gives you a little nudge towards, well, life likey the water.
Life likey the water.
Life likey the waters.
And those Viking missions had really bored people of Mars. They like basically said, it's a no-go, guys. Go home. It's grand. It's done.
Yeah.
So this is hope again.
It's hope again. And that's something that Spirit and Opportunity gave us. It sounds like the end of a book. just two.
Spirit, Opportunity, and Hope.
Oh. But much like many novels that make us sad, Spirit died in 2010, which is something I found really interesting reading about this, was the way that we speak about these rovers. It wasn't that it stopped working, it was that Spirit died. Spirit died in a sand dune in 2010. It got stuck there and it couldn't get out.
Its wheel broke.
It was let go. It was.
But it's so funny because why do people do this? It's like they were supposed to last like 3 feckin' weeks or something, and they last years.
I know, yeah. It's absolutely amazing. I think, but like Opportunity, it worked from 2004 until 2018.
Oh, it's such a blinding success. It's just like
huge.
I guess it is nice as well. It's just people basically paying homage because it is amazing, and the people who do these things, like they're like heroes, man. They're honestly incredible engineers, like amazing.
Oh, this stuff purely it's a passion, isn't it? And to be honest though, if let's say if you're working on the Opportunity or the Spirit or the Odyssey for that entire time, we're only human. We're going to end up building relationships with it, whether we want to or not.
Definitely,
we're going to end up getting all emotive about it and be like, I love that machine that's a million miles away and crawling over red rocks in a environment I could never exist with, but I love it. I love it.
They do, but and then they Disney came out with WALL-E, and that really gave it was completely off of that exact same thought process and just basically drawing emotion out of people for these little robots that are just feckin' out there doing our scut work.
just being all cute.
I think the concluding point on all of that is that you might think that a lot of these rovers look the same, they're already cute, but they are doing completely different things. Like Spirit and Opportunity, they are twins, much like the Vikings. NASA are sending 2 because if one crashes, the other one, they can still do a mission. So that makes perfect sense. One, the wheel fell off after 3 years. The other one lasted like 8 or 10 years. That's what happens. That's why you send feckin' 2, right?
Yep.
And these things get better and better and better. And at our stage now, we're really thinking about getting samples in Mars and send them home. Because the most recent rover before Perseverance was a rover called Curiosity. And what Curiosity did was it actually had a very sophisticated lab on it. And it had a thing called a Raman laser. And it had a type of mass spectrometer. And what these things do is they drill into the rock, they vaporize it into its smallest elements, and they see exactly what the heck is going on there and the percentages of every single element.
Yep.
And that's how you really figure out if life is there. That's how you figure out exactly what's going on. And so that's how they were able to figure out. Curiosity found out there were these things called hyperchlorites. They're a type of salt that is basically saturated with water. And they were really freaking out about this because they were like, yet again, there's another source of water on this feckin' planet that looks like it's a barren, freezing desert, but there are ways that water can still be liquid in certain very strange situations. So that's really cool. And so Perseverance's samples getting back to Earth is where we are right now. That mission that's going to be launched, NASA are very serious about that, and the plans are already in place. And they're, JPL they're basically working on that right now. But really, it's just a very small rocket on a lander. The lander's going to have nothing else. It's just going to be built to shoot a small payload, very light, back out of the Mars atmosphere. And the great thing about the Mars atmosphere is it's extremely thin, so if you want to shoot something out of it, you can actually do it.
Yeah.
Very controlled flight is extremely difficult, but just yeeting something at a single trajectory straight out of the atmosphere is actually a bit easier than you would think. It's actually quite a lot harder on Earth. because of our dense atmosphere.
Yeah, and the gravity too. It's a tenth the mass, but it's 37% of the atmosphere. It's all to do with density.
Exactly, yeah. It's a third of Earth's gravity, and these things are really what we need to start thinking about when we ultimately want to send humans to Mars. And where we are right now, as I said before, is our technology threshold is that we can send something that's about a metric ton to Mars. And most of the experts in NASA say that to send humans, because the fact that it has to have capabilities to be shot back out of Martian atmosphere, it needs to be about 20 tons.
Yeah.
But here's the deal. It's not like it's going to take us 200 years to get this technology, because we've talked about how this is working at an exponential rate.
Mm-hmm.
We will get there. And we'll get there probably sooner than we know. But the question is it a good idea? And do we really want to? And so that is a debate that needs to be had. Mm-hmm. I think it will win. I think people will win over in that the manned missions will happen, because manned missions have happened to the moon. I mean, that's the most daft thing to think of. Yeah. See that big barren rock in the sky? Let's send some people there.
Check it out.
Slap a flag down, take some feckin' rock samples and get on home. Like, it's absolutely daft, but it's amazing.
But it needs to happen. I don't think any of these things are actually to help you in your everyday life, but it's sure as hell true that when you hear about any of these things, you feel a little bit better about humanity.
Absolutely.
Like, you kind of have a moment of, we are going in the right direction. Things are moving forwards. Mm-hmm. And I think it just needs to be a situation where there's actually a benefit to sending people to Mars. And once that exists, it should be done. Even if it's something along the lines of, like, we can't get a rover that does all of the lab work. What if you want to have more than one research question? What if one research question leads to a second one and you need to build another rover? It's a whole lot easier to just have a researcher there who can just do a second experiment.
And that's an amazing point, because what they say in NASA is that what a rover can do in a year, an astronaut can do in a week.
Yeah.
In terms of technology, reusable rockets are an emerging technology that have completely changed the game. Elon Musk and SpaceX and just turning the hype up to 10, a 12
so cool.
off the scale, and just putting those videos out there of having the little marine platform out in the middle of Cape Canaveral in Florida, and they yeet this thing into space, and then they have two little boosters that land.
It's amazing.
Back right beside each other.
Like, they did one recently, and they launched this absolute chunk of a rocket. This absolute monster. Yeah, that was like crashing on its side. And then suddenly it just righted itself at the very last moment and landed. Like, sure enough, it like splooshed itself everywhere in like 2 or 3 minutes later. But it landed. And it just gives you a moment of like, holy moly, how is this a thing? It's so cool.
That is kind of cool. When you said how it changes his attitude like really fast.
Yeah.
If you actually watch the Perseverance landing on Mars, you'll notice that it looks extremely violent. And when the rover detaches from the parachute and the capsule, which it is attached to that whole time that it's going like super fast, when it detaches, it starts rolling out of control, and then it rolls right, and it rolls like 180 degrees and back another 90 and 90, and then finally just above like gets that perfect attitude. And so I think that's something that robotics is able to do and that humans aren't. And so that's how automating these processes is definitely going to bring us there.
Oh, for sure.
People are going to have to be in these things when they're doing that crazy shit.
Yeah.
But we're going to leave it to the robots, and the robots might not get us there super smoothly. We're going to be screaming, or like, I'm going to die! I'm going to puke, and then I'm going to die! shaking in your boots.
I have a feeling it'll have to be different, to be honest, because like the speed of deceleration, like these rockets go from the like edge of the atmosphere on Earth, for example, and they're back on the lander in like 25 seconds.
Yeah.
I'm pretty sure.
Oh, the G's.
Man,
the G's
if you
are crazy.
did that deceleration to a human body, you would be cleaning up the sploosh, which I've decided is the word of the day. You would become a sploosh. You would become a sploosh.
The sploosh juice.
And you'd be like
mopping it up.
You'd be sending in the cleaning people going, don't ask questions, and slipping them a few dollars, being like,
Clean up on Booster 2, you know? There is another big thing that we haven't mentioned, and it's actually the biological effects of space travel.
Yeah.
Look, getting there safely and getting home safely. Yes, of course, that is the first thing you think about, because that's the most dramatic. You smash the surface on Mars, you know, at 40,000 kilometers an hour. Yes, that's not pleasant, okay? And that's great and all, but that might actually be easier than trying to fix the problems of, you know, how do you prevent cosmic rays from getting through your space capsule?
Yeah.
How do you prevent things like cataracts and cancers from being caused from radiation on the way to Mars? Because Mars is a hell of a lot farther away than the moon. You can get to the moon and back in a week. It takes you 7 months minimum to get to Mars.
And over that time, what if you get sick? Any sickness.
Yeah.
You cannot pack, you can't pack a booster and a rocket with infinite medications for all illnesses. So like forget getting cancer from the radiation. That's one problem that can probably be beaten. But what if there's a natural development of an illness like that?
Anything that could impede your work.
Yeah.
If you physically, you're like, I am dying. I need to lie down. And even the poor feckers can't even lie down. They have to sleep standing up. They're just like floating. You know, they have to strap themselves to the wall and cry, you know?
Yeah.
But there is that other thing as well of gravity.
Yeah.
And NASA in the International Space Station have done some amazing work on the effects of gravity on things like bone density, and just causing lethargy in general, and actually just the reduction in your bone mass. You actually get shorter the longer you're in space.
That's crazy.
They're all still unknowns.
Yeah.
And NASA like to test everything. They like to test every single possible outcome that they can at least think of. And that's an easy one that you will want to test before you go, you know?
It's a funny one, though, because I'm pretty sure the conversation about 10 years ago was that if there was a mission to Mars, there was no intention of there being a return mission. You know what I mean? Like, you have to remember that, like, it's one thing to make a tiny little rocket to send something home, you know, a sample or something, but a person? Like, it's not just a rocket, it's the fuel. It's
the life support system.
It's the life support system.
It's food.
It's so many things. It's
just even water. You just think water's like one of the heaviest things.
Exactly, yeah.
And we're just like a big bag of it. We just need it all the time. Honestly, we're an absolute nuisance. And that is the question. And like earlier on today, I was doing some research and I just kind of thought to myself, this isn't worth it. Like this isn't worth the 20-ton gap that we have.
Yeah.
Like, let's just put all of our effort and put all of our budget into these automated vehicles because they're the future. We're so excited and optimistic to get people to these places. And yeah, we can get to Mars. We can. But we can't get to the next solar system. And we can't get to these other places because we're these little water bags and we're super fragile. And if we just send other things that aren't as fragile as us and are really inexpensive in the grand scale of things. Because when you think about it, what was one of the major things that like killed some of those NASA missions? Like the Challenger mission. One of the Challengers blew up and killed like 4 people, including a teacher in America.
Yeah.
That got horrific media coverage. rightly so. It was really sad. And so this is what everyone needs to know when we're doing these things. We get so excited that we kind of forget that this is scary.
I do agree with what you're saying, but I don't think it's done for necessarily the reasons that you're thinking. When we landed on the moon, and it was one small step for man, one giant leap for mankind, in essence, the leap was referring to we're here early. That's what the leap was referring to. It was referring to we're probably not ready to be here, but we're here anyways.
It's crazy that we haven't seen something like that in our lifetime.
Yeah, well, we got a pandemic, so whoop-de-doo.
We got a pandemic, and we got some SpaceX reusable rockets. They are phenomenal.
I kind of feel like, to be honest, our generation in particular, we went through all of history and reading about all these incredible events, and we kind of grew up in the quiet age. You know, there wasn't anything huge. There was a market crash and stuff like that, but there wasn't huge wars. And we were like, gosh, it's been so quiet. I wish I could live through some history. And then we're all realizing that we're living in it. It's a coin flip, man. You're either going to get the bad history to live through or the cool history to live through.
Exactly.
But
that's really funny.
We have our cool history to live through. But like, I think sending people to Mars has much more to do with the psyche of our civilization and stuff. And, you know, it's an important step to kind of live and move to other planets in the solar system. That's the big thing with the type 2 civilization. You know, we're a type 1 and we want to be a type 2.
That's what we want to do.
And this is an important step. I just don't know if it's worth it, because even like we did some reading on terraforming Mars, and man, it has nothing for you. Nothing.
It's super hostile.
It's super hostile. It's not a good thing. Like 1% atmospheric pressure. We take that for granted. We need to times it by 100 to get it to something that humans can actively walk around in. Yeah. And you can't call it colonizing until you bloody do that. So, like I said earlier, it's like the thing. It's so low that liquid water doesn't exist on the surface. It doesn't. Mm-hmm. It sublimates from ice to gas, and the pressure doesn't exist there to have liquid water.
And it just gets released into space.
Yeah. It's crazy. And like, there is evidence that it once had an atmosphere and it had this flowing water. But there's theories that this could have been trapped into the crust.
In that geography class that you weren't listening to in secondary school or high school, that's when your teacher explained the water cycle, and that all that good stuff in the atmosphere is locked up as sedimentary rocks, limestone, sandstone. That's where all of this stuff goes. That's where your atmosphere gets locked up. That's what he's talking about.
Yeah, I'm with you, Aidan. Those people who didn't listen to their geography. Anyways, but the thing is, to fix this problem, there's a number of routes that humans could take. Okay, so they could melt the entire south pole of Mars, and that would
brilliant.
It wouldn't do it, but it would help.
Mm-hmm. With giant space lasers,
which don't exist. You know? And it's not like we'll make the laser. It'd probably be billions and billions of whatever it is. It's absolutely ludicrous. Or there's another option, Aidan. We could heat the entire crust artificially of Mars to release the gas, like a little electric blanket over the entire surface of the planet. No? Oh, I thought that would be. No? Okay. Or if we made over 10 million nuclear fusion reactors, that would be enough energy to produce atmosphere on Mars. That's nuclear fusion, by the way.
That's the one that we're not even there yet.
Yeah, exactly. But over 10 million of them on Mars, and we got an atmosphere, buddy.
And there's barely one on Earth right now.
Yeah, pretty much. We could deep drill into the planet to retrieve all of the compounds from the crust and release it into the atmosphere.
But frack Mars.
Pretty much. But all of Mars. Not just one or two holes, the whole bloody thing.
Not like just that huge Great Grand Canyon.
Yeah, and you have to do all of this under the attack of solar radiation.
Yeah, on a super thin atmosphere on a different planet that is completely inhospitable to you.
The risk of sploosh is very high.
The sploosh risk.
The sploosh risk, there's an extremely high sploosh rate. The more likely thing to happen is that we'll, like The Simpsons, we'll just create these bubbles and just live under these bubbles, and create a small pressurized atmosphere like we'd have on an airplane, and just cover it in like things to protect us from the radiation, and we'll compact it so we're not, getting any of the harshness of the outside, and we'll live in cocoon-shaped houses which will protect us from all of the bad things underneath these giant Springfield-sized bubbles. And the thing is that sounds absolutely ridiculous. And it is still 1,000,000 times easier than terraforming Mars. Compared to terraforming Mars, it's an incredibly reasonable thing to do. Incredibly reasonably. Like, making a giant bubble is basically just brickwork.
It's engineering.
Yeah, you just need to make it.
I heard one really good explanation of why terraforming is just not feasible, is because you have to think about Mars and its history in that it was theoretically, and what people think is 4 billion years ago, it was a lot like Earth now.
Yeah.
And there was water, and a lot of fresh water in these lakes and craters. And that is shown by, you look at where the Perseverance rover is right now, and it's in this crater which has a delta at the edge of it. And it has an inflow river and it has an outflow river. Man. And you can see all that. It's all deposited. So in that delta, there might be life. But the point I'm trying to make is Mars is smaller, and it went through that process of drying up and becoming this barren landscape. And the cycle is done.
Yeah.
It's not like it can go back again.
Yeah.
The only reason that it was balanced and there was liquid water at one time is because it had a molten core. Mars does not have a molten core anymore. Earth does.
Yeah.
We're all good. We have a magnetic field that protects us from the sun's solar wind because we have a molten core.
Yeah.
And so what that means is that when you try and restart this cycle, you might start it for a while. Imagine you built loads of these colonies and just pumped a buttload of greenhouse gases into the atmosphere. You might create a warming effect.
Yeah.
And at the equator, Mars can sometimes be 25 degrees Celsius. That's feckin' perfect. That's really nice. But it's going to crash. And there is no way of the cycle repeating itself because it's done.
It's over, yeah.
It's 4 billion years older than us. It's so far ahead in the future that we should just be taking the lessons from it rather than being like, I want you to be Earth.
Yeah, don't dig up a coffin to perform CPR effectively.
So we were talking about terraforming Mars. That's great. It's not going to work. Happy days. And we're in our Springfield-sized bubbles and stuff.
Yeah, love it.
But none of us have talked about what it means to change another planet. So first of all, maybe we might not know what the life on Mars, or what the life that was on Mars, actually is built up of, and it might be a very different way that life on Earth is built up of. And so this is an idea called planetary protection that was, it was signed like 30 years ago by a bunch of nations on Earth, that basically they said, let's not screw up any of the solar system. Anything that isn't the Earth, we're not allowed to go and throw, try and feckin' grow potatoes. You know what I mean?
Yeah.
Because these things have huge knock-on effects. And I think it's even a moral obligation. It's important that you don't just look at something and go, I want to change it to be useful to me. Mars is useful in its own way. Mars has all the answers of our future. It's not going to help us live right now, but we can figure out what the hell's going to happen to Earth in 2 or 3 billion years' time by studying it. And so that's why we'll go. But not to live there. That's kind of dumb.
I don't know if I totally agree. I agree with some parts of it. Yeah, I agree with some parts of it now, and I think that there should be extra care taken in the potential changing of these things. Like, there's a really interesting thing about how if we were to send people to Mars, what if there were surviving viruses or bacteria that killed the astronauts, and we weren't entirely sure how it would affect Earth? So would you bring the astronauts back? That's another question. Yeah. Because that was a big thing that happened with the moon missions, where the astronauts got shoved into a container for 2 weeks after they landed.
In quarantine. They get quarantined for weeks, don't they? Yeah.
Yeah, well, not anymore, because they've determined that the moon be very dead. But a very funny story from the 3 lads who walked on the moon. They were saying that when they were in this apparently fully enclosed quarantine, on the off chance that there was a deadly, like, living creature on the moon which would kill humanity, and it had to be airtight, they got ants.
Oh my god!
Yeah,
that's so funny.
Yeah, so they got ants in the quarantine.
That is unreal.
But what I like, you were saying that don't change Mars. That's kind of what humans do. You know what I mean? It's what we are doing it very successfully to this planet. Yeah, we have completely contorted Earth to our needs.
And I'm pretty sure there's bags of shit on the moon. There's like sealed bags of shit on the moon. Neil Armstrong and Buzz Aldrin's shit on the moon.
Oh my, they don't talk about that.
Yeah, they're there though, beside the flag.
Well, man, whether or not we eventually do send manned missions to Mars or colonize Mars, anything like that, I sincerely hope that we do leave bags of human poo on Mars at least.
I completely agree.
And on that note, I hope you enjoyed our chat wildly further than we expected about our favourite red planet.
This is the end of the podcast. We hope you enjoyed your time. If you're feeling generous and you're not completely skinned, why don't you give us some of your money? Join our Patreon. Join our Patreon. Join our Patreon. Join our Patreon.